right, we'll switch.
We'll go.
I'm not mad at
We'll
us.
blue.
I know. Oh my god, I'm gonna have to open medals.
You want to start with happy news or bad news? Bad news. If you don't know the unit circle, you need to learn it. You need to be able to work the unit circle inside out, forwards, and backwards. Okay? So that's actually kind of happy news or sad news, depending on how good your unit circle skills are. The main thing I want to do today for the review is I'm going to go back through the unit circle and hopefully start clearing out the cobwebs a little bit. But just to refresh your memory on that, and then a couple other trigonometric approaches. So let's do the unit circle. I don't know how your teachers taught you to do it last year. I'm sure they did a very competent job. I'm going to show you how I teach it, and then you can pick and choose whatever you want.
Is there good news somewhere in there, Reedy?
The good news is today's Thursday, and tomorrow's Friday. And you all woke up alive this morning. It is good news. Life is good, right?
Yeah.
One thing you don't want to do is try to memorize the unit circle. You want to come up with a system in place so that you can quickly calculate what the values of each of these angles are. Okay. I have seldomly seen people succeed if they just take a unit circle, draw it out, and try to memorize it. However, I have seen people draw the entire unit circle on the AP test as a reference and then just keep going back to it. Time is an issue, but if that's what works for you, that's entirely up to you. Okay, so let's start by, first of all, knowing where all the angles are. 0, 2 pi. We're working in radians, by the way, because that's what we work in this class. And so, if you're building an entire unit circle, which is what I'm going to do, I start by doing the pi over 4s, and I just count in a circle. So you know the pi over 4s are all the 45 degrees. So I got a pi over 4 over here, 1 pi over 4, 2 pi over 4, which is pi over 2, because I can simplify fractions, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. Those are the easy ones. We'll come back to those later. This is going to come flooding back to you in a torrent of knowledge. Now that I have the pi over 4s listed, I skip those and I do all the pi over 6s. Pi over 6. 2 pi over 6, which is the same thing as pi over 3. I already have 3 pi over 6. 4 pi over 6, 5 pi over 6, I already have 6 pi over 6, 7 pi over 6, 8 pi over 6, whoops, that's 4 pi over 3, that's a 4, 9 pi over 6, got that, 10 pi over 6, and 11 pi over 6. Yes, sir.
Isn't there supposed to be a pi over 4 on the left?
Did I miss something?
It looks like a 6.
It looks like a 6.
Your pi over 4 looks like a 5 pi over 6.
Oh. Sloppy. And then that's just the pen. I love technology. Good catch, thank you. Okay, confession time. How many people could have done that on their own without any help? Good. Okay, so here's how I teach the unit circle. I'm looking for 2 things. Well, actually 3 things. Big, medium, and small. I'll explain that in a second. There's also a couple things that I remember. Cosine always relates to x or y? X, very good. Sine always relates to y. And tangent is always y over x, or if you prefer, sine over cosine. Those chunks of information will get you pretty far. Senor?
Do we do a lot of identities?
No. Virtually none.
Awesome.
Why do you miss them?
No.
I've never had somebody come back and say, I loved identities.
I was so good at them. Like, that was the only thing on the final that I like really knew.
Wow. These glimpses into your life, Regan, are becoming quite disturbing. Yesterday we had the chicks thing, and now we have the. But it's probably good for you, right? This has become like therapy for you? Excellent. I'll send you a bill later. Sessions. Okay. Let's do the pi over 4s first because they're easy. Are you guys square root of 2 over 2s, or are you 1 over square roots of 2s people? I love 1 over square roots of 2 people. There we go. And I'll come back to the other quadrants in a second. We're just going to focus on quadrant 1 for a second. Okay. Those are the medium values. There are only 2 other values on the units. Well, okay, I'm ignoring the 0s and 1s because I think you can all do that. Yes? Good. There are only 2 other values we're concerned about. They are good and excellent. Help me out here.
3 over 2 and 1/2.
Beautiful. Which one's bigger?
3 over 2.
Good. That's it. There's nothing else going to pop up on the unit circle. Now you just got to know how to manipulate those. So I'm solving a trig unit circle problem. Here's the way that, I don't know if you really want to get into my head, but here's how it goes. I figure out where it is on the unit circle, so we'll do pi over 6 first. And I figure out how do I get to pi over 6 from the origin. So the way I get from the origin is I come out here, and then I go up. Okay. And you'll notice from my little rays that I drew there, one of them is longer than the other. So I traveled in the x direction using a big value. I traveled in the y direction using a small value. Does that make sense yet? Good. So then the last question I have to ask myself is, well, what trig function now am I applying to pi over 6? Let's suppose I want to know the cosine of pi over 6. Well, using this information, I know that cosine applies to x. So I want to know what kind of x value did I use to get to pi over 6. If I used a big x value, the big value for the x would be the square root of 3 over 2. But cosine of pi over 6 is square root of 3 over 2. If that works for you, great. If it doesn't, then go back to what you already know. For me, it works just about anywhere I want to go. I want to know 5 pi over 6. To get to 5 pi over 6, I have big X, small y. Big X, small y. Pick a trig function, tangent. Okay, well, tangent is y over x. So the y value is small, that's 1/2 over the big, which is square root of 3 over 2. Simplify your fraction, you're good to go. Notice I haven't talked about the other 3 because those are just reciprocals. Secant, cosecant, and cotangent. All right, we okay on that? Does that help or hinder or confuse you? Okay, you'll get better at this as we move along, but there's the unit circle. Question?
One more example.
Sure. What location would you like to do? Pick one.
7 pi over 6.
7 pi over 6 is over here. I'm going to change colors just because I'm feeling a little saucy. And pick a trig function.
Cosine.
Let's get a little crazy here. Come on.
Cotangent.
Woo! You want to get that crazy?
Sure.
I didn't expect that. Hope I can do this. All right. To get to 7 pi over 6, I got to go this way. Big X, small y, and the y is negative because it went down. The x is negative because I went to the left. And I'm not going to do the cotangent. I don't play that game. I'm going to do this, and then take my answer and flip it over. You good with that? Okay, so y value. The y value is small, and it's negative. My small value is 1/2. So this is going to be 1/2 over big X value, square root of 3 over 2. And the one thing I neglected is to write the signs down there, but because we're in the third quadrant, negative over negative is positive, you know, okay, good. Fraction over fraction, same denominator, those cancel, and we're left with 1 over the square root of 3. And you got to remember that's tangent, so to get the cotangent, I just got to take that puppy, flip it over, and my final answer would then be the square root of 3. Now, some would argue, well, if I just memorize all of it, I can just fire them off. You don't have to do all that big. That's true, but that's a lot of stuff to memorize on top of all the other stuff you're going to be worrying about, and I'm not a big fan of memorizing. There's about 4 things in this class where I'll say you just got to memorize them. This is probably not one of them. Okay? Any more questions on this before I move on? You just got to get going on it, and you'll get better as you practice, and you're going to practice whether or not you want to, because it's something that pops up over and over again. Now, what happens if we step outside the unit circle? Okay, let's suppose we know that the cosine of some angle theta. By the way, are you all good to go on your Greek letters? Okay, the ones we use a lot of are alpha, beta, gamma, theta, which other? Phi pops up. That's a good one. We don't use deltas that much. Epsilon shows up. These are all lowercase Greek letters, by the way. Because I know you know this as delta, but lowercase delta actually looks like a sad D. What other? I think that's about it. Of course, now that I've said that, you'll get some bizarre one on tonight's homework. Let's suppose we know that the cosine of some angle is, I don't know, let's say 7/12. I have no idea how big the angle is, but I do know that when I take the cosine of that angle, I get 7/12. And I would like to know what's the tangent of that angle. So first thing you need to recognize is that that's not on the unit circle. There's no 7/12 on the unit circle. The next thing is, how do I do that problem? Good. A little more than that, though. You got anything else for me? Well, we will end up using Pythagorean theorem. You remember the problems where you had to draw triangles? It'll come flooding back to you as I work through this. Here's my triangle. Here's my theta. It's a right triangle, so I put the box down there just to show off. Where is the 7 and where is the 12? 7's on the bottom, 12 is on the top. Because cosine is adjacent over hypotenuse. And then, as Dante, right? Dante said, we do Pythagorean theorem. 7 squared plus this thing, let's call it alpha. Alpha squared is equal to 12 squared. So that's 144 minus 49 is 95, so alpha is equal to the square root of 95. I'm going to leave it like that. I don't want a decimal value. And once I get that, then I can find any one of the other 5 trig values. In this particular case, I happen to ask you for tangent. Tangent is opposite over adjacent, so you would get square root of 95 over 7. Okay. Last thing about trig. Any questions on these? Does that look familiar? Okay, it'll come back to you again tonight. The last thing I wanted to show you was solving trig equations, not identities, but equations. So something like 2 times cosine squared of beta is equal to 1. When you're doing equations, you need to check to see, is there a domain restriction or is there not a domain restriction? Do you understand what I mean by the difference? Some problems will say between 0 and 2 pi. Others will not say anything. We're going to not say anything because we want to get a little crazy here. If there was a domain restriction, how many answers will I get? Not in this case. Just 2. If there is no domain restriction, how many answers do I get? Infinity. It keeps going around and around and around. Oh, cosine squared beta is equal to 1/2. What do I do next?
Square root.
Square root. What's the square root of 1/2? How is it? Nope.
1 over 2?
Nope.
1 over square root 2.
Nope.
Oh, 1 over 2.
Nope.
Isn't that like pi over
Nope.
pi over 6?
Oh, there we go. Plus or minus 1 over root 2. Yeah, you got to remember both because there's two locations. So where is the cosine equal to? Actually, we will get 4 answers here, won't we? Yeah, because this is squared. Sorry. Where is cosine of beta equal to 1 over the square root of 2? Pi over 4. 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, that would be if we restricted it from 0 to 2 pi. How do I handle that? So beta is equal to pi over 4 plus, how do I demonstrate that? Yeah, you do the 2 pi k. So we could list all 4 and do 2 pi k, or you could do some other creative stuff, but 2 pi k, 3 pi over 4 plus 2 pi k. And what is this going to do for me? That takes into account revolving around the circle over and over and over. Most of the time, however, you're going to see problems like this where they put a domain restriction, which would allow you to not have to deal with the 2 pi k and just list all the answers. Okey-doke. Questions? It'll come flooding back to you whether you want it to or not. Let me stop this real